Hello students, and welcome to this short little video. This is the video ending chapter 6. This is the video that I should have, or the presentation I should have made to you on Zoom on Thursday, December 1, but my technology wasn't working even though I was ready to go. Wi-Fi was not working for that morning. Anyway, we're going to finish up this chapter about hypothesis testing by talking about the level of significance and p-values. So the level of significance, alpha, this is something that's always given in the question. In hypothesis testing, we're testing at a certain level of significance or a certain acceptable level of risk. So as it says there, sometimes it's called the level of risk. In testing, in hypothesis testing, there are always two possible errors we can make. If we are wrong by saying reject the null hypotheses or not reject the null hypotheses, there are possible errors. So the type 1 error is known as alpha. This is the risk of rejecting the null hypotheses when it's actually true. So the null hypothesis is true, but we say it's wrong. Of course, that's a mistake. We've made an error. We can control a type 1 error by that level of significance, by having relatively small level of significance. So remember a type 1 error. Just remember that it is rejecting a true null statement. A type 2 error is the opposite. It's controlled by other matter, other variables, and other items that we're not going to go into in this course. We're going to learn how to control a type 2 error by perhaps changing some of the wording. So a type 2 error is the opposite of a type 1 error. So on the exam, you'll have to know, I might ask you for one of those types, define one of those types of error. If you can remember one of them, and I would remember the type 1 error, it's a little easier to remember. The type 2 error is simply opposite. So the type 1 error is rejecting a true null statement. A type 2 error is not rejecting it when you should. So you're basically saying that don't reject it, it looks good, but it's actually bad. The problem with these two types of error is that if you decrease one, say decrease the risk of making a type 1 error, you increase the risk of making a type 2 error. So there's a balance. And it comes down to which type of error are you more comfortable with. So on this chart, basically goes through the various conditions. So the condition is the null hypothesis is true or it's false. So we make a correct decision when we not reject the null hypotheses when it's true, and when we reject the null hypotheses, of course, when it's false. Type 1 error, rejecting it when it's actually true. Type 2 error is not rejecting it when it was actually bad. We'll come back to these two slides after we work on a little example. I like this little example here. It really solidifies the difference in the two types of error. So what is the type 1 or type 2 error in each situation? The first situation is what we'll take a look at in more detail. The eye exam to determine if someone is visually qualified to be a pilot. So we'll go to our Jamboard here, and I'm going to write out the types of error we have. Oops. Let me just pause this for a moment. Okay, sorry for that little break. I just had to set up my writing tablet, which I had forgotten about. So let's go through that example of the person getting an eye test, to become a pilot, an airplane pilot. And we will see the consequences of making both of those mistakes, a type 1 or type 2 error. So basically we start off with the statement, the belief that, your eyes are good. The alternate hypothesis, basically what we can prove, is the eyes are not good. Of course, if the eyes aren't good, we don't want that person flying an airplane. So let's look at both of these types. Let's put type 1 down here. Type 1 error. Basically, type 1 error, as you remember, we are rejecting the null hypotheses. Let's just go back there to review that. Type 1 error, rejecting a true statement, rejecting a true null hypothesis, null statement. So type 1 error, reject a true null statement. Of course, if the null hypothesis is true, we don't want to reject it. We want to, not reject it. Whereas a type 2 error is not rejecting. The opposite. Basically saying it's good when it's actually bad. Not rejecting when you should. Okay, let's look at the consequences. Let's put the consequences in blue. Consequences. Rejecting a true null hypothesis for this person that's come in to get his or her eyes examined in order to pass the test to become a pilot. Rejecting it, basically you're saying eyes are not good. You're crossing that off. You are rejecting a null hypothesis. Basically, that's what happens. You're left with the statement that the eyes are not good. So in this case, well, what happens is the person has failed a test, does not become a pilot, failed a test that he or she should have passed, unless, of course, they get a second opinion, and that costs more money to go get you another eye exam. Perhaps this person then has to deal with a career change. There could be some emotional change as well. This person wanted to become a pilot. He's told that, the person failed a test. Now they could all be a little sad. So a type 2 error, you're not rejecting it when you actually should. You basically should say, let's reject the null hypotheses because your eyes are not good. So basically here, the consequence is someone with bad vision becomes a pilot. And of course, that's going to lead to concern, by passengers. Especially if you see that pilot walking onto the airplane and, and he or she is bumping into things or, going into the wrong chair. It's just not good. So the question is, what error are you more comfortable with? Type 1 or type 2? Because there is a chance of making a mistake. So what type of mistake do you want to make? A type 1 error, where basically you fail people that shouldn't fail, or a type 2, where you pass people that should have failed? I think more people are going to be comfortable, unfortunately, making this mistake. Because they do not want a type 2 error. They do not want someone flying an airplane that can't see. So then we are more comfortable. We would rather increase this risk of making a type 1 error. Because, as our point showed here, right in here, that if you decrease the risk making a type 1 error, you increase the risk of making a type 2 error. So if you increase the risk of making a type 1 error, you will decrease the risk of making a type 2 error. They're going to work that way. So in this case, and generally most cases, we will increase that risk of making a type 1 error. You know, say there's a bunch of people trying to become pilots, some with good eyes, some with bad eyes. We would rather err on the side of caution by sending a few people, by failing a few people that should have passed, rather than passing a few people that should have failed. And we can look at the example with, you can work on this with, medical tests to determine if you have a contagious disease. Would you rather send a few people home that aren't sick, or keep people at work that actually are sick? And of course, we're going to side with that type 1 error. So the type 1 error is controlled by the level of alpha, the level of significance. Generally 5%. Alpha is generally 5%, sometimes maybe 10%. But basically that tells us the probability of making that mistake. In order to minimize the risk of a type 2 error, there's various calculations involved in doing this, but the best way is by stating this. Instead of stating that to accept the null hypotheses. Accepting the null hypotheses is basically the optometrist saying, your eyes are good, you passed the test. You got perfect vision. The problem with that is, what if your machines weren't calibrated properly? Or what if you didn't have all the latest testing processes? So as the optometrist, if you are writing your name on that certificate that person gives to the airline industry saying, you passed the test, and later on it's shown that, this guy person has really bad eyes, really bad vision and eyesight, you as the optometrist could be in trouble. So generally, what we say, just like in a court of law, a judge doesn't say innocent, which is basically saying that the null hypothesis is good. He doesn't say innocent. The judge is going to say not guilty, basically because if there were more evidence, if someone did a better job of presenting the evidence, the decision might be different. And the same thing with hypothesis testing. Our decisions will always be to reject the null hypotheses or not reject the null hypotheses. By stating not rejecting the null hypotheses, we're protecting our reputation if something were to change, rather than saying the null hypothesis is good. Same thing with the optometrist, but with the eye example. He or she could basically say that this person appears to have sufficient eyesight. Or based on our latest tests and technology, this person, has sufficient eyesight. Rather than saying this person has perfect eyes, that everything is good. So that's what we mean by the level of significance and type 1 and type 2 error. The second part of this video, which we'll come back to, is going to be getting back into the hypothesis testing and learning how to calculate p-values.